Hi guys, welcome back to Dr. Zahir Math. In this video, we will explore how to find maximum and minimum values of functions of two variables. A key concept in multivariable calculus. I'll walk you through critical points, second derivative test, and how to clearly identify maxima, minima, or saddle points. Let's dive into the concepts step by step. 14.7 maximum and minimum values, which is simply called as local maxima or minima using second derivative test. I'm going to give you the steps. Okay, step number 1. First step, find first derivative fx and fy, which is partial derivative with respect to x and partial derivative with respect to y. Step number 2, put fx is equal to 0, fy is equal to 0. Why? To find the critical points x and y. After that, solve these two equations and try to get x and y. So this point is called critical points. Okay, right. Then after finding the critical points, your next step number 3 is you're going to find second derivative fxx, fyy and fxy. So what you're going to do, find fxx, fyy and fxy. Then step number 4 is find d is equal to fxx multiplied by fyy minus fxy the whole square. Right? Step number 5 is you're going to create a table. Right? So you are going to create a table. What is that? You take the points as a first column, right? And the second one, you're going to write d is equal to f of fxx and fyy minus fxy the whole square. You calculate this one. Then you just put your function fxx. Then you take the decision. What is the decision you're going to take? Whether it's going to become maxima or minima, right? Yes. If d is more than 0 and fxx is more than 0, then the decision you are going to take is minimum. If d is more than 0 and fxx is less than 0 and you're going to take a decision, it is maximum. Suppose if d is less than 0, no discussion, okay? No discussion and no decision. It is going to become saddle points. It's going to become what? No discussion, right? Let me write simply no. If d is less than 0, then it is called saddle points of the function f. Okay? D less than 0 is saddle points, right? Okay. So we are not going to discuss when d is less than 0. Keep in your mind. Okay? So we are going to discuss only what? D more than 0, d more than 0, and fxx is more than 0, fxx is less than 0. Here you are having the points, sometimes 1, sometimes 2, sometimes 3, sometimes 4 also, depends on the problem. Okay, right. So let me explain again the steps, listen carefully. First you are going to find the first derivative, partial derivative fx, fy. Make it to 0 and get the critical points. This is a very difficult points. After you get the critical points, keep it nearby. Then you find the second order derivatives, which is fxx, fyy and fxy. Then you calculate what is d. D is the important thing you are going to calculate. Okay, because the discussion all depends on d. D is equal to fxx, okay, and then fyy minus fxy the whole square, right? So all these things depends on a local maximum and minimum. Keep in your mind. Then step number 5, you create a table with the points d, fxx and you're going to make a decision. Then the last step number 6 is you're going to find maximum. If suppose you discuss this is the minimum. So then the point you're going to put it in the function to get the maximum value or minimum value. Sometimes maximum also you'll get, minimum also you'll get. Sometimes only maximum, sometimes only minimum. Okay, right. So these are the points you need to discuss. Let's go to the first question. Find the local maximum and minimum values. So you're going to underline local maximum and minimum values. and the saddle points. If the saddle points is there, we are going to write. When saddle points, you'll write if D is less than 0 at that particular point. Okay, right. All the things happens at that particular point, keep in your mind. So let's start the solution. Okay, right. So what is your f? F is x power 4 plus y power 4 minus 4xy plus 1. What is step number 1? You are going to find fx and fy, right? What is the partial derivative? It is 4x cube plus 0 minus, you are doing with respect to x, so 4 times 1 y, and 1 is 0. Next, partial derivative with respect to y, 0 plus 4y cube minus 4 into x is a constant, y derivative is 1 and it's 0. So let me simplify this. This is 4x cube minus 4xy, sorry not x, 4y is equal to 0. 4y equal to 0. 4x cube minus 4y is equal to 0, right? Okay, now the next is what? Fy, which is 4y cube minus 4x is equal to 0, right? So we are going to make what? Fx and fy is equal to 0. So fx is equal to 0, fy is equal to 0. So which is 4x cube minus 4y is equal to 0 and 4y cube minus 4x is equal to 0. What is our job? From this situation, from this step, you are going to find the values of x and y. So now I'll write 4x cube is equal to 4y and here I'll write 4y cube is equal to 4x. If you divide by 4, what happens? You're going to get what? X cube is equal to y here and y cube is equal to x. So let us call this as equation 1 and equation 2. Think for a while. We have equation x cube is equal to y and y cube is equal to x. So we need to find x and y. It's a little difficult. So what you are going to do? You are going to do some sorts of simplification. What is that? Usually keep in your mind in this step, you try to put the equation 1 in the second equation or equation 2 in the first equation. So any one thing you can do it. Okay, right. Suppose if I take y is equal to x cube from this. What is this? Y is equal to x cube. This y I am taking here and put it here, for example. So what is your y? Your y is x cube. And then this power 3 I will put it. Again I'll repeat. I have y is equal to x cube. So for y I am putting what? X cube from equation number 1. Okay. Right, is equal to x. It means what? X power 9 is equal to x. Now your problem starts. You're going to find the value of x. As per the equation, x has what? 9 values. Let's see how it is getting deducted. So I'm going to write x power 9 minus x is equal to 0. Okay, right. After that, I'm taking x as common, right? And inside you'll be getting x power 8 minus 1. Amal Mushtarak x I'm taking, right? Whenever two products is equal to 0, we will write each one equal to 0. X is equal to 0 and x power 8 minus 1 equal to 0, right? This, okay, finish. But here the steps continues. I'm going to write this as x power 4 power 2 minus 1 equal to 0. Why I'm writing like this? Because we have a famous identity, a square minus b square is equal to a minus b times what? A plus b. So to use this identity, I'm using this one. So this is of the model what? A square minus b square. Of course, this is 1 square equal to 0. So a square minus b square is what? A minus b, a plus b. So what is in the place of a? X power 4. What is in the place of b? 1. So what happens now? It is going to become x power 4 minus 1 and x power 4 plus 1 equal to 0. Clear? X power 4 plus 1, x power 4 minus 1 equal to 0. Now what I'm going to do, I'm going to just concentrate on this only because I'm not going to concentrate on this. What is the reason? Suppose if I take x power 4 plus 1 equal to 0, what happens? X power 4 is equal to minus 1. So when you take x as square root of minus with the fourth power root, it will give you complex numbers. We are going to find what? Maximum and minimum values on the real line. So definitely complex values are not allowed. So anyway, I'm going to neglect this equation. So when two products are equal to 0, I'm going to write it as x power 4 minus 1 equal to 0 and x power 4 plus 1 equal to 0. This leads to I complex values. I am going to neglect this equation. That means I'm going to ignore it. I'm not going to consider it because the resulting answer is what? I'm getting I. I is a complex numbers which is imaginary numbers. It is impossible on the real plane or real surface. You can say whatever you want. Right. Now next I'm going to do this one. Again I'm going to write x square the whole square minus 1 equal to 0. So I can write this as this is of the model what? A square minus b square. So what is in the place of a? X square. What is in the place of b? It is 1. So what happens now? Which is x square minus 1 and x square plus 1 equal to 0. Right? Still it is continuing. Whenever two products are equal to 0, we can write x square minus 1 equal to 0 and x square plus 1 equal to 0. Again, you just see here x square equals minus 1. If you take x, you will get jother minus 1, which yields a complex number. So please ignore this equation, or you can say neglect. Neglect this equation or ignore this equation. Right. So finally, we'll end up with what? This side x square minus 1, which is going to become what? X minus 1, x plus 1 equal to what? 0. So x is equal to what? 1 and x is equal to minus 1. Previously also we get one values which is x is equal to 0. So we got three values, x is equal to 0, x is equal to 1 and x is equal to minus 1. Okay. Three values we got. You have to put in any one of the equation to get the value of y. We have two equations. What are they? The first equation is what we have. Here it is there. X cube is equal to y and y cube is equal to x. Right. Let me take this equation. Right. So what is the equation? This one. Y is equal to x cube. Let me take this equation. Y is equal to x cube. Y is equal to x cube. I'm going to find the value of y. Okay. Right. You put y is equal to what is the value of x, which is 0 cube. And what is the value of x? 1 cube. I'm putting x equals 1. What is the value of x? Minus 1 the whole cube, right? So you will get what? 0 and you will get what? 1 and you will get what? Minus 1. So from this, what are your critical points? Or you can say the points at fx equal to 0 and fy equal to 0. Critical points are 0, 0 and 1, 1, right? And minus 1, minus 1, right? This is step number 2. Okay, right. After that, we are going for step number 3. What is step number 3? Find the second derivative fxx, fyy and fxy. We are going to find the three derivatives. Okay, right. Let us find fx, fy, fz. Let me write fx. What is fx? So actually we got fx is what? Fx is 4x cube minus y. So fx we got is 4x cube minus 4y. And fy we got is 4y cube minus 4x. Am I right? Yes. 4x cube minus 4y. 4y cube minus 4x equal to 0. Right, we are going to make the derivatives with respect to x. That means you're going to take this derivative again with respect to x one more time, which is going to become what? 12x square minus 0. Fyy, you're going to take this one again with respect to y, which is 12y square minus 0 because x is there. Fxy, you're going to take this one with respect to y. First is 0 and this is minus 4. Okay, right. So what happens now? This is equal to 12x square and this is equal to 12y square and this is equal to minus 4. Step number 4. What is step number 4? You're going to create D. What is D? D is fxx same fyy minus fxy the whole square. Right? So we'll create what is D? D is fxx. How much? Which is 12x square. And fyy is how much? 12y square. Fxy is how much? Minus 4 the whole square. So this is equal to 144 x square y square minus 16. Okay, right. 144 minus x square y square minus 16. Teacher, every time D will be in the expressions, it is with equations or variables. Not necessary. Sometimes D will come as what? Numbers also. Now step number 5. We are going to create what? Table. You're going to create what? Table you're going to create. Yes. What is the table? You're going to give the points, right? Let me create. So these are the points you're going to take, and you're going to create D. What is D? Fxx and fyy minus fxy the whole square, right? This is your D, right? And after that you're going to calculate fxx, which is how much? Fxx second derivative, which is 12x square. So which is 12x square, right? And then you're going to take a decision whether it is maximum or minimum, right? So let us take the points 0, 0, right? And what you're going to do, you're going to put 0, 0 here. So D is equal to fxx. What is your equation? Before that I need to write the equation also. Let me write the equation. What is your fxx and fyy? What's your D? 144 x square y square minus 16. 144 x square y square minus 16. And fx's already is there. So let me create now table. So the first point is 0, 0, right? When I put D is equal to x equals 0, y equals 0, what happens? So I will get 144, 0, 0 minus 16, which is less than 0, right? Let me come. What is the discussion? Then after that you're going to get 1, 1. If you put 1, 1, D is equal to 144 minus 16, right? Which is 128, which is positive 0. Let me take the next point, which is minus 1, minus 1. Of course, x square, y square. So you'll get the same thing. D is 128, which is greater than 0. Because when I put 1 in the x square or minus 1 in the x square, both are going to be same, right? I told you when D is going to be less than 0, no need to discuss anything. Because you will get what? Saddle points at that point. But we are just going to write saddle points. That's it. No need to discuss fxx. Just write saddle points. Okay, right. When D is more than 0, I need to check fxx. So let me put fxx, which is 12 times 1 square, which is 12, which is more than 0, right? If it is more than 0, we are going to get what? Local minimum. So now in this place also more. So fxx at the point minus 1, minus 1. So we are going to put 12 into minus 1 the whole square. Again it's positive. So you are going to get what? Local minimum. Hello Dr. Zahir. We are getting two places in the local minimum. Are we going to get two minimum values? No. Minimum points can occur more. But minimum value will be 1. Maximum points will occur in more places. But maximum value is supposed to be only one value. Keep in your mind. Right? So we suggested local minimum, right? Now we are going for what? Step number 6. So what is step number 6? We are going to put in the function. What is their function? F of x comma y is equal to, what is the equation of the question? The question is x power 4 plus y power 4 minus 4xy plus 1. So we are going to put this point f of 1 comma 1. I told you can put by using calculators, right? You can type the equation x power 4 plus y power 4 minus 4xy plus 1. After that, type this equation. Okay. After that, press the button calc. Then the question is x equals. So what is x equals? You give 1. And after that, y equals. How much? Calculate. It will give you 1. So use the calculator. You will get minus 1. Right? Then again, f of minus 1 comma minus 1 is also minus 1. I told you minimum will occur at 2 points. But the value will be what? Only 1. So therefore, the minimum value is equal to how much? Minimum value, which is equal to minus 1. Is there a maximum, teacher, here? No maximum. Keep in your mind. Because there is no values d greater than less than 0. Okay, sorry, greater than 0. Fxx is less than 0. This situation did not come. So this is the idea for this one. So we got the maximum value. Clear all of you? Clear all of you? Clear or not? Yes. I am planning to do 1 or 2 more questions so that you will get some ideas about maximum and minimum values. Okay, right. Let me start the next question from the exercise. Just a minute. I'll take the questions from the book. right? Okay, so let's start question number 2. Find the maximum and minimum, or you can say local maximum minimum for the function f is equal to, f means f of x comma y, x square plus xy plus y square plus y. Okay, right. So this is the one given. What is step number 1? Step number 1 is find fx and fy, right? What is your fx? Which is 2x plus y. That's it. What is your fy? Which is y, sorry, with respect to y we are doing, which is x plus 2y plus 1, right? So what's your derivative? 2x plus y, and x plus 2y is equal to 1. So what we need to do? We need to find the critical points. That is step number 2. So step number 2, we are finding fx is equal to 0, fy is equal to 0. So when I put this one, I'll get 2x plus y is equal to 0, and here I will get x plus 2y plus 1 equal to 0. When you see these two equations, it looks like a simultaneous equations which is studied in 002. So what I'm going to do, I'm going to write in a proper model, 2x plus y equal to 0, x plus 2y is equal to, this one goes that side, you just put it as minus 1. So now take your calculator and you're going to use mod 5, let me try, I think 2, mod, yes, 5, no, it's 1, mod 5 1, which is two variables. Okay, once you press give 2 equal, no comma, 2 equal 1 equal, sorry, again I'm putting comma, equal 0, 1 equal 2 equal minus 1. So what's the value? You got it? X equals y equals 1 by 3 in my calculator, and y is minus 2 by 3 in my calculator. So we got x and y. Now what we need to do? We need to go for second order derivatives, right? Step number 3. So we are going to find out fxx. So what's your fxx? You're going to take the first one with respect to x again. So what you will get? You will get 2. Then fyy. You're going to do this one with respect to y. So you'll get 2. So you are very lucky you are not getting equations right. And f of xy. It means you're going to do this one with respect to what? Y. So you're going to get what? 1. Now we are going to make a d. Step number 4 is what? Calculate d. So what is d? The formula is fxx and fyy minus fxy the whole square, right? So what is fxx? 2, and fyy is 2, right? And this is 1. So 4 minus 1, which is going to become what? 3. So here we are not getting any expressions, right? So now we can go for table. Step number 5 is table. So how you are going to put the table? You're going to put the points here, and you're going to put the d here, and you're going to put fxx here, and you're going to make the decision, right? Or you can say conclusion, whatever it is, okay? You're going to take a decision. What do you mean by decision? You're going to say it is maximum or minimum, right? So the points are what? I just remember the points are 1 by 3 and minus 2 by 3. So 1 by 3 minus 2 by 3. And d is equal to, just now we calculated, which is 3. Nice problem, right? So d is more than 0. So we can discuss, right? And fxx, what is the equation for fxx? 2 again. The second derivative 2, right? So now what are you going to decide? This is more than 0 and this is more than 0. If it is both of them are more than 0, what are we going to say? Local minimum at the point 1 by 3 comma minus 2 by 3. Clear? Now we are going for step number 6. What is step number 6? You are going to find the minimum value, right? You are going to find the local minimum value. What did I say? Put it in the function 1 by 3 comma minus 2 by 3. Right? So what's your function? I need to go and check. Your function is question x square xy y square y. X square plus xy plus y square plus y. Okay. So you're going to put this point f of 1 comma 3 and minus 2 comma 3. Type this equation in the calculator and then press calc. And then the question will ask x question mark. So you just give 1 by 2 comma minus 2 by 3. Okay, let me start this one. How to put manually, I'll try, and you people can try with the calculator. Okay, right. So let me try manually. This is equal to 1 by 2 the whole square plus 1 by 2 is 1 by 2 or 1 by 3? 1 by 3. So it looks like 2 for me. So it is 1 by 3. It is 1 by 3, right? X and then y 1 by 3 plus y square 1 by 3 the whole square plus y, which is 1 by 3, right? So I'm going to put all these things in the calculator, right? 1 by 3 and then this is y, right? And this is minus 2 by 3. And the next is, this is also y square and this is going to become minus 2 by 3. Sorry, again I make a mistake. And this also, it is not 1 by 3. It is minus 2 by 3. So 1 by 3 whole square plus 1 by 3 negative 2 by 3 plus negative 2 over 3 the whole square plus negative 2 over 3. So finally, if you put all these things in the calculator, you're going to get negative 1 over 3. So negative 1 over 3 is your minimum value or maximum value? Minimum value. Clear, all of you? Clear? So the final conclusion will be this function is having only local minimum and the minimum value is what? Negative 1 by 3 and the minimum value occurs at what? 1 by 3 and negative 2 by 3. So what about maxima? There is no local maxima for this question. Okay, keep in your mind. Right. So in this way we solved 2 questions, right? Yes. So I hope this helped you confidently solve maximum and minimum value problems in calculus 3, right? So this is your 14.7, right? So you'll find the full PDF with solved examples in the pinned comment below. Follow me on X at Zahir262003 for more tips, and don't forget to hit the bell icon and subscribe for upcoming lessons. Keep learning and see you in the next video. Take care all of you. Bye bye.